Hey, welcome back to Mr. Moore and Mr. Rockenstein's Flipped Classroom. Today we're doing a lesson about part and whole fraction problems. So part and whole problems. We've got three goals today. Three goals are, number one, you will be able to name the fraction when the whole and the part are given. Number two, you will be able to name the part when the fraction and the whole are given. And number three, you will be able to name the whole when the part and the fraction are given. Those may not make a whole lot of sense yet, but as we get moving, I think they'll make more sense. So there are basically three types of part and whole problems. In the first one, you get the whole, you get the part, and you have to find the fraction. In the second one, the whole is given and the fraction is given, and you find the part. And in the third one, the part is given and the fraction is given, and you find the whole. I've got a diagram here that helps us think about this. You've got the whole here, a part, and a fraction. Let me just give you an example of how it works. If I put something in the whole, let's just say our whole is 5. So we've got a pie, it's cut into 5 pieces. Somebody takes away 2 of those pieces, and we're left with just 3 pieces. So now our fraction of what's left of the pie is 3/5. The whole is 5. The part is 3. So the fraction is 3/5. Another way to think about the whole is this is the denominator. This is the numerator. So here's the first type of problem where they give you the part, they give you the whole, and you have to find the fraction. And we did a lot of these yesterday, so you got a pretty good handle on these. So here's a set of 6 circles. What fraction of the set is orange? Well, first of all, what's the whole set? Well, the whole set is 6 circles. What fraction? So that's the whole. I'll put that in the diagram here. What's the part? Well, the part is 2. We've got these 2 that are orange. So what's our fraction? Our fraction is 2/6. We were given the whole, we were given the part, we made the fraction. So this was a whole, part, fraction. That's what we had to find. We had to find the fraction. Here's another kind. This is one where we're given 9 monkeys are the whole set. So we're in the whole, we're going to put 9. And then how many monkeys are 1/3 of the set? So they give us a fraction of 1/3. Ooh, let's redo that. They give us this fraction of 1/3. Now we have to find the part. We have to find what 1/3 is. What's 1/3 of 9? So we have to take 9 and break it into 3 equal pieces. So I know from my multiplication facts that 3 can go into 9 3 times. So I'm going to try making 3 equal groups. Here's 1, 2, 3. So I made 3 groups, and they're all equal because they all have 1, 2, 3 monkeys. 1, 2, 3 monkeys. So I have 3 equal groups. So my part, this is my one part right here. So my part is 3. Now you may be saying to yourself, Mr. Rockenstein, you just got done telling us that the whole was the denominator and the part is the numerator. Well, I did. It doesn't look like it though, does it? Because our fraction is 1/3. Well, here's something to blow your mind. 3/9 and 1/3 are equal. How do I know that they're equal? Well, if I divide the top and the bottom of 3/9 by the same thing, let's try. We'll do 3. I get 1/3 because 3 divided by 3 is 1, and 9 divided by 3 is 3. So 3/9 and 1/3 are equal. So that fraction may not have the whole as the denominator and the part as the numerator, but it will make those two will make a fraction that is equal to this piece. All right, so let's go down to the last type of problem. Oh wait, so this one was they gave us the whole and they gave us the fraction, and we had to find the part. All right, now the last one. So if 8 apples are 1/2 of a set, what is the whole set? Well, 8 apples is only 1/2, so 1/2, we know we've got a fraction. And it's only 1/2, so that must be a part. That means that these 8 are only a part of the whole set. We're missing the rest of the whole set. We're missing it. We need to find out what the whole would be. Well, if 1/2 is 8, what we're basically asking ourselves is, what would 2/2 be? And if 1/2 equals 8, then 2/2 would equal, well, 16, because it would be doubled. In other words, for every one of these apples, I would have another apple. So my whole is 16. Now let's do that magic trick again where we compare the two fractions and see if they're equal. So our whole would be 16, so that's 16 right here. Our part is 8. Does that equal 1/2? Well, let's see if we can divide the top and bottom by something and make 1/2. If we divide the top and the bottom by 8, I bet we can make it into 1/2. 8 divided by 8 equals 1. 16 divided by 8 equals 2. So 8/16 and 1/2 are equal. So this problem that we just did was where we had the part and the fraction, and we had to find the whole. All right, let's do another one of these last one, the part and fraction problem, and find the whole. Those are the trickiest. So we've got our diagram here. Let me move it up so we can see it. Let's take a look at this problem. 4 apples are 2/3 of the whole. What is the whole? So let's put in what we've got. We've got the part, which is 4. We've got the fraction, which is 2/3. Now this is tricky. In our last problem, the fraction was 1/2. So it was really easy to figure out what 2/2 was. We just doubled it. We just went from 1/2, which is 8, to 2/2, which is 16. Now here, we're saying that 4 is 2/3. So what we have to do is we have to take this set and we have to divide it in half because this is 2/3. So if this whole set right here is 2/3, then if we divide it in half, we're going to have 1/3. So this is 1/3 and this is 1/3. And we can see that 1/3 equals 2 apples. If 1/3 equals 2 apples, 2/3 equals 1, 2, 3, 4 apples. And then 3/3 must equal 5 apples, 6 apples. So here's the last third. So in total, 3/3 would equal 6 apples. So I'm going to put that over here in the whole. And then let's check it again like we have been. Our whole is 6, so that becomes our denominator. Our part is 4. And we're saying it should be equal to 2/3. So 4, how can we turn a 4 into a 2? Well, I think we can just divide it by 2. Whatever we do to the top, we have to do to the bottom. So 6 divided by 2, does it equal 3? Yes, it does. So 4/6 and 2/3 are equal. So the key here was to turn 2/3 and just find what 1/3 was. And we did that by dividing it in half into 2 separate groups. So we found 1/3 was 2 apples. And once we found that, we could find 2/3 and then 3/3. And 3/3 is the whole. All right. So here's a problem for you to try on your own. It's a number story. Mr. Rockenstein has 12 cans of soup. He wants to donate 1/4 of the cans to the food shelf. How many cans will he give to the food shelf? So you have to decide what kind of problem this is. Is this one that gives you the whole, the part, and you find the fraction? Does it give you the part and the fraction and you find the whole? Or does it give you the whole and the fraction and you find the part? So you do this problem on your own, and then you should pause the video while you do it, and then when you're done, I'll solve it and you can take a look. So go ahead and pause the video right now. All right, so you've had a chance to do this problem. Here's my explanation. Mr. Rockenstein has 12 cans of soup. He wants to donate 1/4 of the cans to the food shelf. How many cans will he give to the food shelf? Well, the whole is 12 cans because that's the whole thing. I want to give 1/4 of them away. So I have to figure out what 1/4 is. So I need to kind of make 12 cans of soup somehow. So I'm just going to make some of these. We'll make these into cans. 4, 5, 6, 7, 8, 9, 10, 11, 12. And I need to make these into 4 equal groups. So 12 divided by 4 is 3. So I'm going to do groups of 3. 1 group, 2 groups, 3 groups, 4 groups. Remember, this tells me how many groups I need. I've got 4 groups. How many are in each group? Well, in each group, there's 1, 2, 3 cans of food. So my part is 3. Now to check, I'm going to take this fraction that I can make out of the part and the whole. 12, the denominator, that's the whole. The part is 3/12. And see if that equals 1/4. Well, how do I turn 3 into 1 using division? I can just take 3 divided by 3, and that does equal 1. Now does 12 divided by 3, because whatever I do to the top, I have to do to the bottom, does that equal 4? 12 divided by 3 does equal 4, so these are equal. So the answer to my question is 3 cans. That's how much I'm going to donate to the food shelf. All right, that's the end of the video. Rewatch anything that you didn't understand. Write down some questions. This is tough stuff, so I recommend watching the video twice if you have the time. See you tomorrow. Remember to bring any questions you have with you.